Osmosis is the movement of water molecules across a semi-permeable membrane from an area of greater concentration to an area of lesser concentration. Here we have red blood cells in solution. The red blood cell has a semi-permeable membrane. Tonicity is the measure of the osmotic pressure of two solutions separated by a semi-permeable membrane. It is commonly used when describing the response of cells immersed in an external solution. Like osmotic pressure, tonicity is influenced only by solutes, such as sugar, that cannot cross the membrane. There are three classifications of tonicity that one solution can have relative to another. Those three classifications are isotonic, hypertonic, and hypotonic. If a solution is hypotonic, there is a greater concentration of solute within the cell than there is in the surrounding solution. As a result, water molecules enter the cell. As the water molecules continue to enter the cell becomes larger and larger. If water molecules continue to diffuse into the cell, it will cause the cell to swell up to the point that lysis or rupture may occur. In this demonstration, dialysis tubing and a sugar solution are used to demonstrate a hypotonic solution. First, a 3 centimeter length of dialysis tubing was cut. The tubing was briefly soaked in water, then rubbed between the fingers to open the tubing. One end of the tubing was twisted, doubled back, and secured with an orthodontic rubber band to prevent leaking. The tubing was then filled with a concentrated sugar solution and sugar granules. The second end of the tubing was also twisted, making sure that no air molecules were in the cell. An orthodontic rubber band was used to secure the second end as well. The completed cell was weighed on a digital balance and then was gently placed in a beaker of tap water. After 30 minutes, the cell was removed from the beaker, gently patted dry, and again weighed on the digital balance. As you can see, there was a significant gain in weight from the water molecules entering the cell. If a solution is hypertonic, there is a greater concentration of solute outside the cell than there is inside the cell. As a result, water leaves the cell and the cell shrinks. In this demonstration, a 3 centimeter length of dialysis tubing and concentrated sugar water again were used. The cell was created as before, except this time tap water was poured into the dialysis tubing cell. After both ends were secure, the cell was weighed on the digital balance. The cell was then placed in a beaker of concentrated sugar solution. After approximately 30 minutes, the cell was removed from the sugar water solution and again weighed on the digital balance. As you can see, the cell lost a significant amount of weight and has become very flaccid or lacking in firmness. When a cell shrinks, it is said to be crenate. If a solution is isotonic, there is an equal concentration of solute both inside and outside of the cell. Although water molecules continuously move into the cell and out of the cell, the concentration on both sides of the semi-permeable membrane remain the same. In this demonstration, a cell was again formed from the dialysis tubing and was filled with tap water. After both ends of the cell were securely fastened, this cell also was weighed on a digital balance. The cell was placed in a beaker of tap water for half an hour. As you can see, the weight of the cell remained constant.